We're looking at intercepts of rational functions today. And remember, an intercept is just where it crosses an axis. So our y-intercept is where it crosses the y-axis, and our x-intercept is where it crosses the x-axis. And they're actually really not that intimidating once you get the hang of them. So think about, what is x equal to at the y-axis? Well, x always equals 0, right? So at your y-intercept, your x is always going to equal 0. And your x-intercept is along the x-axis. What does y equal at the x-axis? Well, y is always equal to 0. So your x-intercept, excuse my voice, is where y equals 0. So how do we find these in an actual function? Well, I always say the y-intercept is the easiest one to find. All you have to do is plug in 0 for x and simplify. So if I come over here and I'm looking for my y-intercept, I put in a 0, I do f of 0, which means put in 0 for x. So I do 0 there, a 0 there, and a 0 there. So that becomes 0, and that becomes 0, and that becomes 0. So I get negative 9 over 27, which is negative 1/3. And that's it. That's my y-intercept. And I can write it as a point where x equals 0 and y equals negative 1/3. That's where it crosses over the y-axis. If I want to find my y-intercept of this function, all I do is plug in 0 for x. And I notice that when I plug in 0 for x, I get 0 in the denominator, which is a no-go, right? Which means this one actually doesn't have a y-intercept because there's an asymptote there. We would have found an asymptote there at 0. So there is no y-intercept. So we would say that there is none. Not 0 or anything like that. It's just none. What about this one? If I plug in 0 for x, I get negative 70 over 21, which simplifies to negative 10 over 3. So I can write my y-intercept. Y-intercept as 0, negative 10/3. And this one, if I put in 0 for x, I get 5 over 10, which is 1/2. And I can write that as 0, 1/2. And that's the y-intercept again. Now, what if I want to do the x-intercept? It's a little more challenging. It's where y equals 0. And you're asking, how do I make y equal 0? Well, remember, f of x is y, right? So I make y equal 0. And then I solve this equation, right? So to solve this equation, I'm going to multiply both sides by this denominator to get rid of it, right? And when I multiply both sides by x squared minus 12x plus 27, x squared minus 12x plus 27, what I notice is that actually cancels out the denominator completely, and this times 0 just stays 0. So what I end up with is 3x minus 9 equals 0. And this is really handy to know once you understand x-intercepts, is that when we're looking for the x-intercept, really all we're looking for is when does the numerator equal 0. That's it. That's all we're looking for. We actually don't care about the denominator, because when the denominator equals 0, we have a horizontal or a vertical asymptote or a hole. So when the numerator equals 0, we have an x-intercept. When the denominator equals 0, we have a vertical asymptote or a hole. Okay? So those are two different things. So now we have the numerator equal to 0, and we solve. If it needs to be factored, we're going to factor it. This one doesn't, so we add 9 to both sides, and we get 3x equals 9. And we divide both sides by 9 or by 3, and we get x equals 3. So this x-intercept is at x equals 3, and then y equals 0. Remember, because our x-intercept, y always equals 0. So our x-intercept is 3, 0. And this helps us a lot when we're trying to graph them. Okay, so if we want to look for the x-intercept here, we're going to, again, remember we set y equal to 0. And when I multiply both sides by the denominator, it cancels out, and I'm still equal to 0 on the bottom, or on the left side. So I have 0 equals 2x squared plus 5x plus 2. And then this is a quadratic, so we know how to solve this either with a quadratic formula or with factoring. It's a lot easier to do it with factoring. So this one factors, let's see, 2 multiplies to 4 and adds to 1, so it would be 4 and 1. And so then if we pull that out, we get x plus 2 and 2x plus 1. And again, if you need more practice factoring, that would be a good thing to practice on Delta Math or some other way, or Ed Ready. So we factor that, and then we say, when is this equal to 0? Well, this would be equal to 0 at -2 or at -1/2. Therefore, we actually have two x-intercepts here. We have the x-intercept -2, 0, and we also have -1/2, 0. So it actually crosses at two places. There can be two x-intercepts, there can't be two y-intercepts, otherwise it wouldn't be a function. So if we look at this one and we want to find the x-intercept, we set y equal to 0. And again, the denominator cancels out when we multiply both sides by the denominator, becomes 0. So we have 0 equals x squared minus 3x minus 70. And I look for something that multiplies to 70 and adds to -3, which would be -10 and 7. So where is this numerator equal to 0? It's equal to 0 at 10 and -7. So my x-intercepts are -7, 0, and +10, 0. Those are my two x-intercepts. All right, last one. We're going to ask ourselves, where is y equal to 0? Well, that's where the numerator is equal to 0. So I have 0 equals 2x plus 5. This doesn't need to factor. I subtract 5 from both sides, and I get -5 equals 2x. So I get x equals -2/5. And there we go. My x-intercept is -2/5, 0. That's where it crosses the x-axis.